Lesson 4.2, this is the review drill that starts the lesson. Convert each radian measure into degrees. We want to remember that when we're going from radians to degrees, we're going to multiply by 180 over pi. So I've got pi over 6 times 180 over pi. The pi's cancel, and I have 180 over 6, which is 30 degrees. For part B, again, I'm going to multiply by 180 over pi, and the pi's cancel. I'm going to go ahead and do some division before I multiply the 4 times the 180. 180 divided by 3 is 60, and 4 times 60 is 240 degrees. For number 2, I'm asked to convert each degree measure into radians, so I'm going to be multiplying by pi divided by 180. So I have 120 degrees times pi over 180. So I have 120 divided by 180 pi. They can both be divided by 10, and 12 and 18 can both be divided by 6. So I'm left with 2/3 pi. For part B, I'm going to do the same thing. 300 degrees times pi over 180. End up with 300 divided by 180 pi. They can both be divided by 10, which cancels out the zeros. And then each of these numbers can be divided by 6. So I'm left with 5/3 pi. For number 3, I'm asked to convert the revolutions to degrees. Since I'm going to degrees, I'm going to multiply by 360. So 1/4 of a revolution times 360 degrees. That gives me 360 divided by 4. And I know 36 divided by 4 is 9. Since it's 360, it will be 90 degrees. Same thing in letter B. I'm going to have 2/3 of a revolution times 360 degrees in a circle. I know that 360 can be divided by 3, and that's 120. So I'm left with 240 degrees. Again, on all of these, you could use a calculator and just take 360 divided by 4, or 2 times 360, and then divide that by 3. For number 4, we're going to convert revolutions to radians. And radians, remember, a full circle or a full revolution is 2 pi. So I'm going to have 1/3 times 2 pi, which is simply 2 pi over 3. Remember, when we multiply with fractions, it's just multiply the numerator, multiply the denominator. Letter B, I've got 3/4 times 2 pi. And I know that 2 over 4 becomes 1/2. So I'm left with 3 pi over 2. Right, so now we're going to start our notes for arc length from a subtended angle. The circumference of this circle is 18 pi. Remember that circumference is the distance around a circle. Let's write that down. Distance around the circle. So, in other words, if I was to travel all the way around the circle, I will have traveled 18 pi. The central angle is 10 degrees. So we're going to draw a central angle. This is just a sketch, so we don't need to have a protractor out. We're just going to draw a sketch and say that that's 10 degrees. We are asked to, so 10 degrees is the magnitude of the arc. So my arc right here is 10 degrees, and I want to find the length of the arc. What's the actual length of this arc? Well, I realize that the entire circle is 18 pi, and that this is a portion of the circle, or fraction of the circle, times the circumference. It's sort of like when I was finding, well, we're only doing part of a revolution, we would multiply by 360 degrees, or 2 pi, because we were looking for the magnitude. But since we're looking for the length, we're going to take that fraction and multiply by whatever the circumference is. So what is the fraction of this circle? Since it's in degrees, my fraction is 10 out of 360 degrees, times my circumference, which is 18 pi. I'm going to go ahead and use my calculator for this. We are going to do exact answers for right now, so I'm not going to multiply out the pi. I'll just do 10 times 18, and then divide by 360, and I get 1/2 pi, or pi over 2. That is the length of this arc right here is pi over 2. All right, let's go to my next one. My circumference is 24 pi, so this is supposedly a larger circle, and the central angle, I'm just going to draw a little sketch of a central angle. I'll make it a little bigger than the last one since it's 25 degrees for this one. And I'm looking for the length of this arc. So again, my arc length is going to equal my fraction of my circle, which is 25 out of 360 degrees, because the entire circle, the whole circumference, would be 360 degrees, and I only want to look at 25 out of the 360, times the 24 pi. Again, I'm going to leave pi in the answer. So on my calculator, I'm going to take 25 times 24, and then divide that by 360, and I get 1 2/3, 1.67 pi. If it's 1, I'm going to go ahead and convert that to a fraction, which would be 5/3 pi. 1 2/3 is the same as an improper fraction, 5/3. If you didn't know that, you can just hit math, enter, enter, and you will be able to get the 5/3 pi, or 1.67 pi. Again, to get that fraction, I just hit math, enter, enter. Okay, so let's go to our next page. It says that the circumference is 18 pi. All right, so the distance around the circle is 18 pi, and the central angle is 350 degrees. Okay, so what I'm going to do is I'm going to draw like this, and the angle I'm looking at is this one. So do you remember on the previous page when I had that this was 10 degrees? Well, this is the other 350 degrees. Okay? So let's see. I've got a fraction of my circle. I have 350 out of 360 degrees times my 18 pi. In case you forgot, we're doing arc length equals my fraction of the circle, that piece of the circle, times the circumference. So I'm going to go ahead and put this into my calculator, 350 times 18, and then I'm going to divide by 360, and I get 17.5 pi. Now I put 2 stars here because what I wanted you to realize is that on the problem from the previous page, I'm going to see if I can get these to fit here together. When it was 10 degrees, I had 1/2 of a pi, so the length of this is 0.5 pi. And then we found out in this picture that the length of this is 17.5 pi. Well, if this orange is 17.5 pi, and this right here that I can do in pink from the other page is 1/2 of a pi, 17.5 and 1/2 gives me 18 pi, which is the entire circle. So I just wanted you to see that this is 17.5 pi, and this is 1/2 of a pi, which gives me 18 pi. All right, let's go on to this next problem. Now we're told that the circumference is 10 degrees, and the central angle is 82 degrees. Okay, again, we're just doing a sketch of the angle. Doesn't need to be perfect. This is 82 degrees. We're asked once again to find the length of the arc. I'm looking for this length right here. So my arc length is always just writing this over and over so that we can hopefully remember this, that its arc length equals fraction of the circle, that portion of the circle, times the circumference. So in this problem, my fraction is 82 out of 360 degrees times 10 pi. So I'm going to go ahead and put this into my calculator. I'm going to take 82 times 10, and then I'm going to divide that by 360, and I get 2.27 repeating, or I can say 2.28 pi. And let's see if I convert that. I could convert it. It says it's 41/18 pi. I think I'm just as happy with 2.28 pi as I would be with 41/18 pi. Sorry, I didn't want 8 to look like that. Okay. All right. In example 2, we know the circumference, and this time we know the length of the arc, and we're looking for the subtended angle. So I'm going to draw a sketch. I don't really know what the angle is, so I can draw it any way that I want. I know that the distance around the entire circle, that the circumference is 15 pi. I know that the length of the arc is 7 pi over 2, and I want to find the angle. So some angle, I don't know what the angle is, we'll call it theta, divided by 360 times the 15 pi equals 7 pi over 2. So I know that whatever my angle is divided by 360 times the circumference is 7 pi over 2, because remember, fraction of the circle times circumference equals arc length. So I'm going to multiply. I need to get theta by itself, so I need to multiply by 360 over 15 pi on both sides.